Hello, and welcome to today's lesson on evaluating integrals using the substitution method. We are tasked with evaluating the integral of the square root of x divided by the square root of x plus 1 with respect to x. To solve this integral, we can use the substitution method, which involves making a substitution to simplify the integral. In this case, let's choose the substitution u equals the square root of x. This will help us transform the integral into a simpler form. Let's differentiate both sides of this equation with respect to x to express dx in terms of do. The derivative of u equals the square root of x with respect to x is 1 over 2 times the square root of x. So do equals 2 times u times dx. This allows us to express dx in terms of do. Now, substitute u for the square root of x and dx for 2u do in the original integral. We are now left with 2 times the integral of u squared over u plus 1 do. After substituting and simplifying, our integral becomes something easier to evaluate. Now, let's evaluate the integral 2 times the integral of u squared over u plus 1 do. We can use polynomial long division to make this easier. Divide u squared by u plus 1. After division, we get u minus 1 plus 1 over u plus 1. This means that our integral becomes 2 times the integral of u minus 1 plus 1 over u plus 1 do. Now, split the integral up to make it easier. We can write this as 2 times the integral of u do minus 2 times the integral of 1 do plus 2 times the integral of 1 over u plus 1 do. Now, let's evaluate each integral separately. The integral of u do is u squared over 2. The integral of 1 do is u. The integral of 1 over u plus 1 do is the natural log of the absolute value of u plus 1. Putting it all together, we have u squared over 2 minus u plus the natural log of absolute value of u plus 1 plus a constant. Finally, substitute back in for u, which is the square root of x, and we're done. The integral is x minus 2 times the square root of x plus 2 times the natural log of the absolute value of the square root